Let's take a look at how StruCIM can be used to create automatic welding programs for putting subparts on a structural steel beam. From the welcome window, I'm going to install the standard welding work cell. What you can see here is that we've got a robot suspended from a rail. The robot can slide horizontally. It's got an arc welding gun mounted on it. And then we've also got clamps here to hold the beam in place. We've got two of them, one for each end, and you'll see how that mounts shortly. And then it can rotate the assembly around so that welds can be performed from several angles. I'm going to bring up the Import CIS2 file menu, bring in a sample file that we've created. The entire file contents are read here so that we can see what assemblies and parts are available in the file. And when I bring in the B40 assembly, it's going to create geometry for every part, construct that assembly with everything in the proper position, and it's also going to analyze the weld data for all the welds in the CIS2 file so that you see some small directional markers here that show the angle bisectors so that we know exactly what angle to weld those surfaces at. Just going to hit View All here to get a better view. Close the import file, and now I'm going to bring up the Move to Welding Table menu. I'm going to select the B40 member in our assembly and move it to the weld table. The first thing I'm going to do, so you can get a good view here, is slow down my graphics update rate. And I'm going to zoom in on this clamping mechanism. When I say move to weld table, you can see we place it in position. We drop it down in place, and then we clamp the members so that when the assembly rotates, you've got a firm hold on it. All that's left now is to create the program and run a simulation. Go to the Generate Program icon in the toolbar and simply click Generate Part Program. What you see here is a very high-level representation of the welding process. We've got positioning commands that slide the robot horizontally along the rail and also rotate this assembly clamp so that the weld can be performed. I'm going to click this switch to put the simulation step mode. Move the cursor to the beginning of the program. You can see that right off the bat, the robot is moved into place. The assembly is rotated. And if I take a look at where the robot is located, I can see that it's trying to weld directly underneath itself. So from past experience, I know that it's going to work out better if I move the robot down a bit. So if I change this positioning statement, I can do that by simply double-clicking on it. I'm going to move it to about 215 centimeters down, absolute reference from the end of the rail. Now when I run that statement, you can see the robot slide a little further down. If I continue along, you can see the first weld is performed. Now I want you to note that this plate is very close to the flange, and we do have a collision there. In our next video, we're going to show how to address that. Continue stepping through my program here. And if I zoom out and slow the update rate down a little bit, I'm going to turn off step mode, simply run through the program. You see the robot sliding down further so that it can weld the next plate in place. You see a weld performed along the web here. It's going to rotate the assembly a bit. Perform a weld along the inner flange of the beam here. Now notice that when I move the camera, I'm simply holding down the Alt key. And with my 3-button mouse, I can pan, zoom, and spin the camera to get a better view of the process. Now that things are working smoothly, I'm going to speed the simulation back up a bit. Zoom out to get a better view. These clip angles are going to be put in place, starting with the one on the top here. Got 3 different welds. Then the assembly is going to rotate so that we can get to the one that was on the bottom of the beam. And that's complete. Our simulation's done. Robot moves to a ready position.